Hello students, welcome to the cbse chemistry lecture series. In this particular video, we are going to discuss about coordination compounds which belongs to the 12th standard chemistry chapter. So in this coordination compounds, first we have to see what is meant by coordination chemistry. Actually, the branch of inorganic chemistry dealing with the study of coordination compounds, we can call this coordination chemistry. Okay, the branch of inorganic chemistry dealing with the study of coordination compounds is known as coordination chemistry. Yes, before that we have to define what is meant by coordination compounds. The word coordinate is nothing but, already we discussed types of chemical bonds: ionic bond, covalent bond, coordinate bond. So we have to know the definition for coordinate bond. Say for example, if it is we have to know what is meant by covalent bond. The covalent bond is nothing but mutual sharing of electrons. Mutual sharing of electrons between the combining atoms. Say for example, hydrogen. If these two hydrogen atoms having valence electron 1, so both are mutually sharing this one electron each and attaining the nearest to noble gas electronic configuration of the atom helium. Because the helium is what? 2 electron structure and 8 electron structures are stable based on the octet rule. Duplet or octet rule. So in this case, the sharing of electrons, both atoms are mutually sharing one electrons. That type of bond we can call as what? Covalent bond. Whereas in the coordinate bond is nothing but the sharing of electrons from any one of the combining atoms. That is the definition. Sharing of electrons from any one of the combining atoms. Say for example, you can think about ammonium ion, how it forms. So ammonia, NH3, having a lone pair of electrons and the H plus atom. There is no electron in these things. These two want to form a bond between this nitrogen and hydrogen H plus. Therefore, that type of bond, for bonding we need 2 electrons. Here sharing of electrons from any one of the combining atom. That means nitrogen will give the electron for bonding formations. So H. So the electrons given by the nitrogen atom, therefore the arrow mark shows from nitrogen to hydrogen. That means that indicates that both the electrons will from the nitrogen atom. This type of bond only, or say coordinate bond. So totally it's what? NH4 plus. So this coordinate bond is exist in this type of coordination compounds. That we'll see one by one. To know more about coordination compounds, first we have to know the certain basic things like what salts. You know that salts, say for example, sodium chloride is a well-known example. So NaCl, Na plus Cl minus. Normally, this is called a simple salt. That means it containing only simple cation, simple anion. Okay. The another one containing a addition or molecular compounds. Molecular or addition. You can take a 2 simple salts. 2 simple salts. On crystallization, we are getting a salt which is further classified as two things, as one is a double salt, another one is a complex salts. Now we have to know the differences between double salts and complex salt, and also some examples which are all double salt and what basis we are classified or what we are differentiating the double salts and complex salts. You can take, first we will take a double salts. See here, for example, you can take a ferrous sulfate FeSO4 plus ammonium sulfate. These two simple salts on crystallization, we are getting a double salt, that is FAS, or you can say more salt. The formula for ferrous ammonium sulfate is FeSO4 dot ammonium sulfate dot 6 molecules of water of crystallization, water of hydration. So this is called a FAS, ferrous ammonium sulfate, or more salt. So this is one of the example for double salt. Let us discuss complex salts. So in these complex salts, you can take a similar things. What you can take a ferrous sulfate plus potassium cyanide, 2 molecules. What it gives? FeCN twice plus K2SO4. The ferrocyanide is treated with excess of potassium cyanide, that is 4 more molecules. It will becomes K4 FeCN6. So this we can call as what? Complex salt. Now we have to differentiate it. Double salt and complex salt. In what way we have to differentiate it? See, this double salt in water, what will happen? It will be ionized into ions, Fe2 plus ions, ammonium ions, and sulfate ions, split into ions. Whereas in this case, this complex in water, what will happen? This will be split into ions like K plus, 4K plus, plus FeCN6, 4 minus. So what is the difference? If we check in the salt analysis, you maybe studied the test for ions like sulfate ions. If you add a barium chloride, barium sulfate, white precipitate will be precipitated. From that we are confirming that what sulfate ion is present in the solutions. Say for example ammonium hydroxide, if you add some sodium hydroxide and Nessler's reagent, it gives a brown color precipitate that indicates the presence of ammonium ions. Similarly, test for Fe2 plus ions also there. So here the ions are all retain their identity. Whereas in this case, if you check with what? Fe2 plus ions, it won't answer for the not respond. That means this Fe2 plus is in the complex. The whole complex will answer for the test, not the individual ions. So here the ions lost their identity. Ions like Fe lost their identity. So that is the difference, main difference between the simple salt and complex salt. Okay. Now we'll see the difference between double salt and complex salt. Okay. So first one. So you can take two simple salts in equimolar proportions. Two simple salt in equimolar proportions. Whereas in the case of complex salts, may or may not be in equimolar proportions. May or may not be in equimolar proportions. That is the first difference. Second one, it exists only in solid state. Double salt exists only in solid state. Whereas here, complex salt exists in both solid and liquid. Or aqueous. Then you have to, third one, here the double salts exist only as an ionic compounds. On water it will be dissociated into only ions, whereas here it will be in the complex, not in the ionic form. Not in ionic form. Sometimes we can say not correctly what fully I say, not ionic, may or may not be ionic, may or may not be ionic, or mostly in complex form. Okay. The another one difference is what means in double salt the metal ions show the normal valency, whereas in the case of coordination compounds, two types of valencies are there. One is a primary valency, another one is a secondary valency. That all we will discuss in the concepts. Just now we are know only the differences between double salt and complex salt, few points. Now we will see types of complexes. Or how the complex ions will exist, in what are the different ways. Say for example, K4, Fe, CN6. So if you analyze this one, what will happen means K plus 4 plus plus Fe, CN6, 4 minus. Here this complex is in the anion, so it is an anionic complex. You can put a complex as CX. Okay. The another one, you can take a Cu NH3 4 times SO4. This is another complex, will be dissociated into Cu NH3 4 times 2 plus SO4 2 minus. Here this is what? This is a complex is in the form of cation. So what is a cationic complex? Cationic complex. Then another one example is a both cation as well as anionic complexes are, we can call this what? Neutral complex. Say for example, you can think about NiCO 4 times. We are not putting any charges on this one. This is called examples for neutral complex. So in all these cases, you can say a simple cation, this is complex anion. Here a complex cation, simple anion. These are the combinations. Apart from that, both Ions may be a complex one. Say for example, Cr NH3 6 times, yes, in this case it is exists in the form of what? Complex cation, complex anion. These are the three possibilities of formation of complex salts. One is a simple cation, complex anion. Another one is what? Complex cation, simple anion. Another one is a complex cation, complex anion. So these are the three different existence of complexes. Apart from the neutral complexes also, that we are not putting any charges on that complex. So you have to say these are the different types of complexes in coordination compounds. Thank you, students. If you have any doubt, please mention the comment box. Thank you.